Hello, everybody. We're going to continue our lesson on section 4.1 and talk about another example of solving a one-step equation. Okay, in this case, we have z divided by 7, actually negative z divided by 7, equal to 3. If I want to get the variable z by itself, there's a little typo here, just so you know this should actually be z. You must get rid of this negative 7. Okay, that's the problem right here. Z is being divided by negative 7. The operation between z and negative 7 is, as we just said, division. To get rid of negative 7, we have to do the inverse, or the opposite of what's already being done. The inverse of dividing by negative 7 is multiplying. Okay. So here, what we're saying is, this is showing our multiplying. If we multiply by negative 7, then we notice that this negative 7 and this negative 7 will divide out, and we'll be left with just, let me just change this color, we'll be left with 1 times z. Mr. Cody, please contact the main office. Mr. Cody. On this side, though, when we multiply 3 times negative 7, we don't get 1, we get negative 21. Okay, so that means that z, we don't really need this 1z, we could just write as z. Z is equal to negative 21. Okay. So I want you to get the idea that if we're trying to undo an operation, to isolate or get a variable by itself, then we need to do the opposite operation. Now, one of the things I really like about solving equations is that I can check my solution. So I can check and see if I got the answer right. If this is a quiz or a test and I want to know if I got the answer right, I can actually check it to see before my teacher marks it. So you can check your solution by substituting your answer into the left side and right side of the original equation. If both sides are equal, then your solution is correct. So we want to check our solution to example 2. And in our previous video, we saw example 2 was w minus 6 equals 8, and we thought w was 14. Okay, so the question was w minus 6 equals 8. Now, if I want to check, I'm going to set up a left side and right side chart. Okay, on the left side, I'm going to write what was on the left side of my original equation. So that's all of this stuff, w minus 6. Okay, and on the right side, I'm going to write what was on the right side of my chart, of my original equation. So that's 8. Okay, and it's like there's an equal sign in the middle. Okay, now I thought the answer was 14. That's the answer that I got back when I did example 2. So I'm going to substitute 14 in for w. I should have said my answer was w equals 14. So where I see w, I'm going to replace that with 14. And I'm going to check. If w was 14 and I took away 6, do I actually get 8? And the answer is yes, I do. If I do 14 minus 6, I get 8, which means that w had to be 14 for this equation to be true. If w is 14, then the left side equals 8 and the right side equals 8. And we can say, since, this is a symbol that means since the left side is equal to the right side, therefore, notice the dots are in a different order here. Therefore, the correct answer is w equals 14, or w equals 14 is correct. Okay. Thank you, and we're going to continue on for another video on section 4.2. Have a great day.